The reason for learning about complex numbers is because now when we have quadratic equations that don't touch the x-axis, or quadratic equations where the discriminant of the quadratic formula is less than 0, we now can actually find the solutions. So in problem 6, we're going to find the solutions of the quadratic equation 2x squared plus 32 equals 0. In order to solve this, I'm going to think about this like any other algebra equation. It doesn't matter that it says x squared. Pretend like it says 2x plus 32 equals 0. What would you do in order to solve this? Well, wouldn't you first subtract 32 and then divide by 2? The only difference with the problem on the left is that when I get to this last step, it's not going to be x equals negative 16. It's going to be x squared equals negative 16. So, in order to finish solving the problem, I have to get rid of the square. How do you get rid of it? You square root it. When you square root it, though, you have to put this nice little pretty symbol in front of the square root sign, plus or minus. Quadratic equations have two solutions. Whether those two solutions be two real numbers, the two numbers are the same number, or the two solutions are now going to be imaginary instead of no solution. What's the square root of negative 16? Well, you take out an I for the negative, and the square root of 16 is 4, so it must be plus or minus 4i. Now I want you to try this on your own. What are the solutions of each equation? Remember that when you get to the end of the problem, only take the square root of the number if it's a perfect square. If it's not a perfect square, like for example the square root of 5, do not turn it into a decimal. Leave the square root of 5 in the final answer. If you don't like the method that I just used to solve this, I'll give you an alternative method that will always work. The other way of doing this problem is to use the quadratic formula. The quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But you need to know what a, b, and c are. Remember, a, b, and c come from ax squared plus bx plus c equals 0. So in this particular equation, a is equal to 2, c is equal to 32, but there's no b because there's no term with an x. So b must be 0. In order to use the quadratic formula, x is equal to negative b, I put it in parentheses, plus or minus the square root of b squared minus 4ac all over 2a. When we first introduced the quadratic formula, I wanted you to solve or simplify this in a certain method. And that certain method was first simplify that. There's no such thing as negative 0, so we'll worry about that in a minute. Then identify the number that is under the square root sign, which is negative 256, and then simplify the denominator, which is 4. All right, so the square root of negative 256 is going to be an imaginary number. So let's take the square root of 256. I bet the square root of 256 is a perfect square. It's going to be 16. Yeah, I'll put it there. So plus or minus 16i over 4. Well, 16 divided by 4 is 4, so the answer must be plus or minus 4i. And I still got the answer of plus or minus 4i by using the quadratic formula. The nice thing about the quadratic formula, rather than the way I actually solved it in problem 6, is that you are left with the plus or minus symbol in the final answer, and you don't have to remember to put it in yourself. For some problems, the only method of solving is using the quadratic formula. Remember, I said that the quadratic formula is nice because it works every time. We've learned some other methods of solving quadratics, like using the graphing calculator. But the graphing calculator won't tell you the exact solutions if the solutions are irrational numbers, and it won't tell you the solutions at all if the graph doesn't even touch the x-axis, in which case the answers are now imaginary rather than no solution. So if you graph 2x squared minus 3x plus 5, you'll notice it does not hit the x-axis. So what do? Let's use the quadratic formula. A is 2, B is negative 3, and C is 5. X equals negative B, watch for those double negatives, plus or minus the square root of B squared minus 4AC all over 2A. Please simplify this in parts. Positive 3 plus or minus the square root of, only do the part that's under the square root sign, and please type it into your calculator at one time. Do not do it in parts. You should get negative 31 over 4. Well, the square root of 31 is a decimal. So, in order to finish the problem off, I'm just going to put the little I in front of the square root sign and leave the answer like this. Now, you can leave the answer like this, or the book writes it as 3/4 plus or minus the square root of 31 over 4i. They would like to write it in real and imaginary components, and I don't care which way you write it. I believe on the test we usually write it in this format. Now I would like you to try these two problems on your own.